There's no better leader and advocate of additive manufacturing than our keynote speaker, Dave Burns of the X1 company. A group of us met with Dave last night, and I'm just absolutely thrilled that he chose Baltimore to come to talk with us about additive manufacturing on our launch of this exploration. Dave will educate us on the transformative qualities of additive manufacturing. He will inspire us to see his vision. He will help you to understand that additive manufacturing is a disruptive technology that redefines manufacturing in some fundamental systemic ways. It will bring back manufacturing through innovation that transforms the processes and creates new rules of engagements. So folks, please join me in welcoming a good friend, David Burns, a visionary transformational leader, as he leads us on our journey today. And Dave's going to speak from the floor. Dave?
Thank you, Mike. Can everybody hear me okay? Good place to start. Well, I appreciate the introduction, although it's actually sort of daunting because the notion that I'm actually most of that is sort of overwhelming to me. I really am grateful for the chance to be here and honored to have the opportunity to speak to you. I did meet with a small group of people last night, and quite honestly, the Baltimore community is fortunate to have such a group of passionate, visionary people who want to make this community a better place. And so, from my perspective, RMI is great, and you're really lucky to have people who are this actively involved in your community. So. Thank you for the invitation. As I told Mike, I'm really honored actually to have the chance to speak to you. I've been involved in manufacturing now for my entire work career, which spans about, I think, 34 years this year. And so I know a lot about making parts, and I tend to know a lot about manufacturing technology, but I struggled a bit to try to understand what I might say to you that you would find important, because what I think is important maybe isn't important to you. And what I'm going to do actually is I'm going to keep my remarks relatively brief. Hopefully I'll say something along the line that you'll find stimulating, and we'll have a good chance for a question and answer exchange when I'm done. And I pondered this question of what should I say to you? And I actually thought about it for weeks and weeks. And I finally came up with a title for this presentation, which I'll share with you in a minute. And I travel a lot for work, and I was on a plane the other day, and the flight attendant said, as I was sitting down in my seat, this is an announcement. This plane's going to Minneapolis. If you don't want to go to Minneapolis, this would be a really good moment to get off the plane. So let me ask you two questions. First one, are you interested in manufacturing? And the second one, do you believe that the US has a manufacturing problem? If your answer to either of those questions is yes, then fasten your seatbelts and put your tray table in an upright and locked position. If your answer to both those questions is no, then this would be a really good moment to wander out and get a cup of coffee for about 30 minutes or so. Although I need to tell you, if you do that, actually I'm going to sort of point to you and make sure everybody notices as you leave. Okay. Manufacturing technology is a technology grouping of companies that provide products to others to make stuff. It really is as simple as that. In the US, it started out basically as the machine tool business, but since then it's evolved to people who make machines, who make inspection devices, who make robotics, and nowadays also make, as you see in the upper right-hand corner, additive manufacturing equipment. So manufacturing technology is this grouping of products that support people who make stuff. And this is what I've done my entire life. For 27 years, I worked at and eventually ran a company in New York that was a machine tool company, one of the most successful in the world. And it was a great career, and I enjoyed it, and I learned a lot about the world, and I learned a lot about manufacturing during that time. I left in 2005, and I was sort of convinced I wasn't going to do that anymore because it's a tough business. But along came a friend of mine who said, I'm starting a company down in Pittsburgh called X1, and we're going to do additive manufacturing. And I studied it and I thought about it, and I decided at that moment in time that what additive manufacturing was going to provide to the world eventually was so transformational and so disruptive, and it was going to be so active in breaking the paradigms that we understood about manufacturing that I really wanted to be part of it. So after pondering it for a while, I thought, I want to be part of this. So we started X1 Company. And I learned about the technology, I got excited about it, and I became a disciple of additive manufacturing. And for years, I traipsed around the country accosting individuals and saying, I want to talk to you about this amazing thing, it changes everything. And do you know how when you're talking to somebody who maybe dated your daughter or borrowed your weed trimmer, you know, and so they owe you the courtesy of listening to you, but the eyes glaze over, and it's like, okay, get done with this pretty soon. For a long time, that's sort of the way it was. And I don't know what happened, but about a year ago, somebody flipped a switch. And we went from not being able to find anybody to talk to about this thing we called additive manufacturing to suddenly everybody was talking about additive manufacturing. Call it the Industrial Revolution 2.0. That's out of the New York Times a few months ago. I can't think of another technology that has so many implications for new industry. That's out of Forbes magazine 4 weeks ago. As the technology evolves and becomes ever more accessible, there's no doubt it's going to transform the way our children's generation will work, play, learn, and build. Huffington Post a couple weeks ago. Additive manufacturing technologies create a world of possibilities. Terry Wohlers, who's a world international consultant to manufacturing technology companies. 3D printing technology has already changing the world, but we haven't seen anything yet. Okay? So, when I started to read all this stuff, I finally figured out what this talk was about. And this talk is about additive manufacturing. Is it snake oil or is it salvation? I'll let you judge by the time we get done with this. To make sure that we're all on the same page, I'm going to do a small primer on additive manufacturing, because actually there's people in this room, I will guarantee you, who know more about this than I do. Guaranteed, okay? But on the possibility there's some people who aren't completely grounded in it, let's talk about what this thing is that we call additive manufacturing. The first notion of additive manufacturing is that it begins in digital space. Now, this is easy words to say, but I need you to understand that additive manufacturing begins with the fact that you have digital data to provide to your manufacturing process. Without digital data, you can't get started. And that is not a trivial question when you think that we've got 300 years worth of designing stuff that wasn't done digitally. Okay, so you need digital data. You can't additively manufacture without it. You've got to get whatever idea or parts you want to make into digital space. And there's really two ways to do that. Left-hand side, you can capture it. I'm sorry, Amy. Left-hand side, you can capture it with a scanner. Scanning technologies are amazing nowadays. Okay, I take an object, I can use a scanner, I can use CT technology, I can do all kinds of stuff. But I can actually take an object and I can grab the digital data that is about that design. And once I've got it, I've got it. Or alternatively, I can use a computer-aided design station and I can create a digital design from scratch. But one way or another, I have to have it to make additive manufacturing go. Once I have, now imagine for a second, I've got an object. I got this object right here. This cool object. So I've got a point cloud in space of this object digitally. There's another set of softwares that take that object in space and slices it. And the additive manufacturing process depends on the fact that we create those slices digitally so that we can manufacture the object in layers. I think of it this way. This is a 3D object. I've got the data about it. and I've now sliced it into layers. I sliced it into a set of sequential two-dimensional layers, one on top of the other, to build it up, okay? So what we do in additive manufacturing is we download those layers to a machine and, go ahead. We download those layers to a machine, and layer by layer, we recreate that object in physical space using a set of materials that match this digital design that we have delayered. You know, and somewhere along the way, I've got this Star Trek transporter thing in my head about how this happens. It's not that, but we go layer by layer and we build objects in a variety of materials using a variety of different binding techniques to make the object that we have just delayered in space digitally, okay? Kind of makes sense? I hope so. There's really, there's a multitude of ways that we go about this, but in the end, there's sort of three ways we create these layers. One would be we would take liquid and we depose it layer by layer. Okay, and I guess the analogy I think of is, think of making a cake. And I'm squirting this viscous material called frosting, and I want to put a blue layer on, and then a red layer and a green layer, and I go around and around. Eventually I build whatever I want frosted. So I can take a viscous material and I can depose it layer by layer according to the digital data that I've sliced previously. A second way I can do it is I can put down a bed of powder and I can melt selectively the particles in that layer that I want melted. And what I do is I melt the particles together that I want melted, and I melt them in such a way that they grab the particles underneath, so the two layers join each other. And then I can go on and put layer upon layer and build an object that way. Or the third way is I can use chemicals. I can use a print head, and I can put down a layer of powder, and out of that print head I can spray binding material that grabs those particles next to each other that I want grabbed, and it grabs the particles underneath so the layers hold together, and layer by layer I build the object up in space. So conceptually you go, seems pretty easy. And it's not easy, trust me, but it is not conceptually that difficult to grasp, okay? Digital data, slice it, download to a machine, layer by layer, build objects. This process is to be contrasted directly with what we would call subtractive manufacturing. So for years, the way we've made stuff is we've taken blocks of material and we've whittled them down to something smaller that looks and is the size and material and shape we want. Hundreds of years of subtractive processes, 10 to 15 active years of additive processes. Additive versus subtractive manufacturing. I wanted to be sure you had a mental image of the way that I perceive this contrast between subtractive and additive manufacturing, okay? So, subtractive manufacturing is this. Okay, that's subtractive, and additive manufacturing is this. Any of you who want to unbuckle your seatbelts now and get off the plane, this would be a good moment to do it, okay? I've been doing this a long time, and I clearly understand the differentiation between these two questions, subtractive and additive. I will tell you that additive manufacturing, at its core, destroys the basic paradigms that we've accepted as the constraints of manufacturing for all the years we've done it. I'll guarantee you that. And we're going to talk about that a bit as we go. We talk about